Imagine a realm so remote, so enigmatic, that it lies at the very edges of our solar system. A cosmic frontier that challenges our understanding of space and time. This is the Oort cloud, a hypothetical shell of icy bodies that envelopes our solar system like a vast, shimmering veil. Though invisible to our eyes, its presence shapes the dynamics of our cosmic neighborhood and holds secrets that could reveal the history of our solar system. But what exactly is the Oort cloud, and why does it remain one of the great mysteries of astronomy? Hello, and welcome to Z. Please don't forget to subscribe and hit the bell icon. Join us as we journey into the depths of this fascinating frontier. The story of the Oort cloud begins with humanity's ancient fascination with comets. Cultures across the globe have marveled at these celestial wanderers, interpreting them as omens, signs of change, or divine messages. The Babylonians, Greeks, and Chinese all recorded their appearances, often attributing significant events to these fleeting visitors. As our scientific understanding progressed, astronomers began to recognize patterns in the behavior of these icy travelers. The concept of the Oort cloud was first proposed in 1950 by Dutch astronomer Jan Oort, who sought to explain the unpredictable paths of comets that seemed to originate from all directions in the sky. Oort's groundbreaking hypothesis emerged from observing the trajectories of long-period comets, leading him to theorize that this distant region could be the source of these icy objects. The Oort cloud is often divided into two distinct regions, the inner Oort cloud and the outer Oort cloud. The inner Oort cloud, sometimes referred to as the Hills cloud, is theorized to be a denser region that serves as a transitional area between the Kuiper belt and the outer cloud. This zone is believed to harbor more gravitational interactions, allowing for a greater exchange of material among its icy inhabitants. The outer Oort cloud, on the other hand, is envisioned as a more diffuse and extensive area, potentially housing billions, perhaps trillions, of icy objects, remnants from the early solar system that never coalesced into larger bodies like planets or moons. This spherical shell may extend from 2,000 to 100,000 astronomical units from the Sun, a scale so vast it's difficult for our minds to grasp. To put that in perspective, 1 astronomical unit, or AU, is the average distance from the Earth to the Sun, about 93 million miles, or 150 million kilometers. Comets are the most famous inhabitants of the Oort cloud. These icy bodies, composed primarily of water, carbon dioxide, ammonia, and various organic compounds, represent a time capsule of the early solar system. As they journey toward the Sun, they begin to heat up, their ices vaporizing and releasing gas and dust in spectacular displays. This transformation is what makes comets visible from Earth, often appearing as bright, glowing orbs with long, ethereal tails stretching across the sky, tails that can extend millions of kilometers. Long-period comets, originating from the Oort cloud, can take thousands or even millions of years to complete their orbits, giving them an almost timeless quality as they traverse the solar system. These celestial visitors not only dazzle our eyes, but also provide invaluable insights into the primordial materials that formed our solar system. Icy relics that hold clues about its origins and the conditions necessary for life. The dynamics of the Oort cloud are influenced by various factors, including the gravitational pull of nearby stars, the Milky Way's gravitational field, and even the effects of molecular clouds. When a star passes close to our solar system, within just a few light years, its gravitational force can disturb the orbits of objects within the Oort cloud. This disturbance can send some of these icy bodies tumbling toward the inner solar system, where they may become visible as comets. The interplay of gravitational forces creates a cosmic dance that has been occurring for billions of years. This process is believed to be the mechanism behind the sporadic appearances of long-period comets, which can arrive from seemingly random directions, further underscoring the dynamic nature of this distant realm. Despite its significance, the Oort cloud remains elusive to direct observation. No spacecraft has yet ventured this far, and the vast distances involved pose enormous challenges for astronomers. However, scientists are continually developing innovative methods to study the Oort cloud indirectly. By tracking the trajectories of comets and analyzing their compositions, researchers can infer the properties of the Oort cloud's population. Observations of long-period comets, such as Comet Hale-Bopp and Comet Neowise, have provided valuable data, hinting at the diverse materials that populate this region. Furthermore, advancements in telescopic technology, such as the use of infrared and radio wavelengths, promise to enhance our understanding of this distant realm, offering tantalizing glimpses into its structure and composition. The Oort cloud is often contrasted with the Kuiper Belt, another region of icy bodies located beyond Neptune. The Kuiper Belt, home to dwarf planets like Pluto, consists of relatively stable orbits and extends from about 30 to 55 astronomical units from the Sun. In contrast, the Oort cloud is thought to extend much farther and is spherical in shape, surrounding the solar system like a protective bubble. This distinction underscores the complexity of our solar system's architecture and the processes that shaped its evolution. While the Kuiper Belt is relatively well studied, the Oort cloud remains a tantalizing mystery, waiting to be unraveled. The Kuiper Belt is primarily composed of short-period comets, which have predictable orbits. The Oort cloud is theorized to produce long-period comets that can appear unexpectedly and from any direction. The mysteries of the Oort cloud ignite our imagination and fuel our curiosity about the cosmos. As we continue to explore the solar system, the potential for future discoveries remains vast. The upcoming generation of space missions, such as the proposed Interstellar Probe and the Comet Interceptor, may one day probe the edges of the solar system, providing direct observations of the Oort cloud and its inhabitants. These missions are designed to study not just comets, but also the icy bodies that populate this distant region, potentially unlocking secrets about the formation of our solar system and the dynamics that govern it. Each discovery will bring us closer to answering profound questions about the origins of our solar system and the nature of the objects that reside in this distant frontier. To understand the Oort cloud is to trace the history of our solar system itself. For centuries, astronomers have observed comets and recorded their appearances, leading to a deeper understanding of these icy wanderers. From Halley's Comet, which has been documented for over 2 millennia, to the spectacular comet Shoemaker-Levy 9, which famously collided with Jupiter in 1994, each observation adds a layer to our knowledge. With each new discovery, we learn not just about comets, but about the processes that formed our planetary system. The data collected from ground-based and space telescopes, coupled with theoretical models, allows scientists to piece together a picture of how the Oort cloud influences the solar system's evolution. As we continue this quest for knowledge, we also learn more about the fundamental nature of our universe, how it began, how it evolved, and how we fit into this grand tapestry of cosmic history. The Oort cloud may also hold clues to the very formation of the solar system itself. It is theorized that the building blocks of our planets and moons originated in this distant region. The interaction of gravitational forces from the Sun, the planets, and nearby stars played a critical role in shaping the orbits of these icy bodies, ultimately determining their fates. Some researchers speculate that the Oort cloud might even have connections to other star systems, suggesting a dynamic exchange of materials across the galaxy. Such ideas prompt us to consider the larger implications of the Oort cloud. Could it be a remnant of a primordial molecular cloud that birthed our solar system, or does it play a role in seeding life across the cosmos? The study of the Oort cloud not only enriches our understanding of our solar system, but also encourages us to ponder deeper questions about life and existence. If we find that some of the icy bodies in the Oort cloud harbor organic compounds or the ingredients necessary for life, it may change our perspective on the conditions required for life to emerge. It raises the tantalizing possibility that, just as comets have delivered water to our planet, they may also carry the seeds of life across the universe. This notion propels humanity's quest for knowledge and invites us to look outward, inspiring the next generation of astronomers, explorers, and dreamers. As we gaze into the depths of space, the Oort cloud serves as a reminder of the vastness and complexity of our universe. Though it remains shrouded in mystery, this distant realm holds secrets that could illuminate the early history of our solar system and the conditions that fostered the formation of planets, moons, and possibly life itself. With every new observation and every advancing technology, we edge closer to unraveling the enigmas of the Oort cloud, our solar system's outer frontier, inviting us to wonder what other cosmic mysteries await us in the depths of space. The Oort cloud stands as a beacon of exploration, inspiring generations to look up and ask, what lies beyond?